Okay, so I will demonstrate the Mimic setup that we have on the Nachi robot. So just to explain what the setup is here, we have the Mimic tracking system, a tracker here, this, and we have a base station over here, and then we have a Nachi robot that we're controlling. It has a Wagner painting gun mounted, and I have my own painting gun here, and what we want to do today is to copy my motions on painting motions to the robot. Okay, so let's get started. First thing is you place the tracker in your 0 point, and then you calibrate. And I'll mount the tracker here, and we're ready to do some programming. I'll start the recording here, and I'll stop it like that. Now we have made a program, and we'll check how that looks. Oh, I don't have to do that here. I'll check how that looks like on the robot. So now we can go through the program like this. And if there's any places where we feel that we didn't get close enough to the program, we can move back to the place in the program where we want to change it. And let's say from here we want to go a bit closer to the part. So what we can do is we can start the tracking again, move it a bit down, and then continue the program. So now we're a bit closer, so I have made a change to my program. I can make as many changes to the program as I want, and I do it all using the joystick and jogging the robot or correcting the robot through that. We can also, in the tuning phase that we are in here, we can also change other things. We can lock the axis, so constrain the axis to a specific plane. We can scale my movement so that if I move 1 meter here, the robot will move 1 centimeter. So this is very useful if you do very small corrections. You can also change the robot speed, so you can override the user speed and then change it to have a constant feed rate. And finally, you can also override the outputs. So let's say I want to start the. So here we have the paint spray is on. If I wanted to, and here we see it's closed, but I can override the setting so that it will be on for longer, like this. So I can override the output settings. I just have to select the right one. What the hell? Jeg ved ikke, hvorfor en de brugte her, hvis jeg siger. Okay. Like that. And now I also changed the output so that I can control where I do the painting and the timing of the painting. And that timing is tightly connected to the position where the robot is. Finally, after doing the tuning, I jump into playback, and I can see the whole path being controlled. Okay. So I sometimes get questions like, what should I do if I have 2 or multiple painting devices? So I have different colors or different nozzles. So what you would normally do is you will add to the robot, you need to add multiple nozzles so that you can control each of the nozzles on different robot outputs. On the Mimic side, you can do multiple different things. So you can have an extra painting device or paint gun like this. So you have 2 paint guns, one with the one option, one with the other option. And the only thing you have to do is when you use one Teach device, you put the tracker on that. And to do the other Teach device, you add it to that Teach device. And then when you do the teaching, you have to set up which TCP point on the robot, so which tool you're using, if you're using the paint gun number 1 or you're using the paint gun number 2. This way, the program knows which TCP point you're using. So you can use as many TCP points as you want. You just have to calibrate it on the robot. Another question I sometimes get is that if you have a more advanced painting tool that automatically can change paint or change the nozzle type, how do I integrate that with the Mimic? So basically Mimic is able to trigger inputs, digital inputs and outputs. And what you can do is on the robot, you can set up a script to listen for the triggering of an input from the Mimic, and then you can execute all the code you want in order to set up your painting device in the proper way. So this is a way that you can use more advanced equipment, painting equipment, together with the Mimic system. But the Mimic basically communicates through digital I/O to the robot and through the robot. This is also how we typically would set up conveyor tracking on the robot, or through the robot. So the encoder you hook up to your robot as you usually would do, and the tracking is also gone through that, and the Mimic will do the recording and matching of the path that the robot is doing. It will do that through the robot. Another thing that I'm often asked about is that how do the Mimic system behave? So how does the Mimic system take control of the robot? And how do I start programs from the Mimic system? And the short answer is you don't. You start programs from your robot as you normally would do. You create a robot program, and then in your robot program, you can hand over the control of the robot to the Mimic system and ask it to execute specific Mimic programs. And then Mimic will execute those programs, and when it's done, it will come back to your robot control, to the program in the robot, and then you have the possibility of doing anything like in-feed or out-feed or whatever you want the robot to signal. All the usual stuff you have to do also with the safety equipment, you hook that up to your robot. So the Mimic system really works as a slave system to the existing robot controller. Okay, so we just created a program a few minutes ago, and often Mimic is used in situations where you have a lot of different programs. So you have small batch production, for example. If you don't want to create a program again, or if you get a part back and you want to recall that Mimic program, you can go and look in here. Here you can see a big list of all the different programs that we made here, and there's essentially no limitations to the amount of programs you can do. These programs you can also go in and edit again, so you can change them, you can play back, you can also simulate them. You can also export them. So if you just want all the points, all that Mimic program, so a Mimic program is essentially a huge list of points separated with I/O and events. You can get that out of the system and manipulate it in offline programming tools such as RoboDK or other offline robotic software. I'm also often asked about the joystick that we're using. So today we are using the Wagner Control Pro painting gun. Here you can, of course, you can change the nozzles as you want to, but if you're using other painting equipment, the only thing you have to do is attach the Mimic OEM version. So this part up here, if you attach that, you can get the tracking unit up here and mount it like that. So this part you have to attach to the tool that you normally are using, and the only modification you have to do to the tool is make sure that a small button down here is attached so it will register when you press the paint gun. All of that communication is wirelessly through the tracking system. So the Mimic system is very configurable. It works with many different robots, and I'll just show you the settings screen where you can go and configure the Mimic system. In here we can select the robot and the robot driver that we want to use. So currently there's a KUKA driver and there's a Nachi driver. You can also use the UR, and we have a generic robot driver if you have partners that can make their own drivers to the Mimic system. In here you can change the limits of the robot and some of the dynamics of the robot, so the Mimic will keep with within those constraints. Here, for example, we have a MC20 robot, we have the MZ07 robot, huge list of different Nachi robots and KUKA robots that you can just take out. So that's the robot database. We go back. We also have the option to add different trackers. So right now we have 3 different trackers. We have the IR tracker. It's this system. It's wireless and works very well in a big workspace. We have the EM tracker, which is an electromagnetic tracker. It works very well for small workspace where you don't have a lot of metal. So for this painting gun, it's not so good. And we have a simulated tracker that is something you can use. So it's like a jog teach pendant you can open on your screen, and then you can jog the robot around using that. So that's the tracking systems or joysticks you can add to the system. You can also set up many different tools. So the most important part of the tool is the TCP point. This is the point that you control on the robot. So for any system you set up, you calibrate a TCP point on your joystick, that would be here, and you calibrate a TCP point on your robot, which is the same point but on the robot. Selecting that when you do the teaching is important, or when you do the runtime is important in order to get the right control of your robot. You can also, for programs you already made, you can also change the TCP point or copy it and copy it to another TCP point. If you had, let's say, you made one program with one type of paint, and then you actually want the same program with another type of paint, you can just change the TCP point for that program and it will run with that new type of paint. The Mimic system has an I/O mapping, so it communicates with the robot through I/O and also with other equipment through the I/O of the robot. To do that, we have an I/O mapping between the tracking system here and the joystick, the buttons of the joystick, and then to which output or input on the robot that you want to control. So this you can set up specifically. I can choose, I want the tracking input 1 to map to the robot output 6. This mapping helps you set up the control. So for example, if I know that I have connected my painting system to the output, so the 0 output of the robot, then I need to set up a button on my joystick to map to controlling that 0 output on the robot. This way we can control equipment and a lot of different equipment through the robot. In order to use the Mimic system in more advanced tasks, you need to set up reference frames. So that's the user frames. That's where all the programming, all the paths that we do are related to those frames. In this setup, this is my user frame here. And the program that I'm doing here will relate to this 0 point that I have right here. For the robot, I also set up a 0 point. And that 0 point has the same reference to the path that I'm going. And that's the way we can relate. That's how we calibrate the robot movements to the human movements. This calibration plate looks like this, and it fits nicely with the tracking unit, but it also has 3 points which you use with the robot to calibrate how the user frame relates to the robot base. For that, we have a simple system, a calibration wizard, where you basically go through these 1, 2, 3 points, and then the system will calibrate the reference frame. When you do the playback of your programs, you can decide which reference frame you want to play that program on. So let's say on a big robot like this, I could actually have 2 more sinks just standing with to one side, both sides of the robot. So in that case, I would actually use 3 reference frames. I would design a reference frame for each sink, and I would only make 1 program. And for each of the 3 executions I do, I would select a different reference frame for the execution. And then the robot will move to the right sink and do the painting. You can also use the mimic system for just teleoperation your robot. This can be useful in some cases. Often I use it just to verify that I'm set up correctly. So in this case, I want to position my paint gun in the same orientation as the robot and position, and then I can start the tracking of it like this. So this way I can check if my TCP point is actually the same and if it feels okay, and if it's not, then I can go and do those changes. So the teleoperation is mainly something you use for debugging it, or if you need to make something quick check of the program. You can also record the teleoperation motions like this. Okay. And like we did with the teach mode, we can play that back and see how that works. So now I just made a program by teleoperating it. This is not as accurate as when you do the teach mode, but again, in some cases, teleoperation can have its uses.